Alright, so the question was to find an equation of the line that is tangent to the graph of f of x equals 1 over square root x minus 1 and parallel to the line x plus 2y plus 7 equals 0. So what I did, my first step, is to find f prime of x. And the reason I did this is because f prime of x is the equation of the slope at any point on the graph f of x. Alright, so we're going to need that later on. So we have our equation f of x equals 1 over square root x minus 1. This is, for me, just a better way to write it. This makes it easier for me to derive it. F prime of x equals negative 1/2. You pull your negative 1/2 down, x minus 1 in parentheses, to the negative 3/2. Alright, normally this would be a chain rule, but the inside derivative of this function is just 1. Alright, so what I did step 2 is I found the slope of the given parallel line up in the original problem. So the given line that they give us that we wanted to find a tangent line parallel to was x plus 2y plus 7 equals 0. Now in order to find the slope of this line, I just solved for y. Subtracting x and 7 from both sides, you get 2y equals negative x minus 7. And then you get a y equals, you divide both sides by 2, you get a y equals a negative 1/2 x minus 7/2. And what that negative 1/2 means, that's the number we were looking for, that's our slope. Our slope equals negative 1/2, and that's going to be our m for our line equation later on. Alright, so what I did step 3, we're going to use this negative 1/2 and set f prime of x equal to negative 1/2. Because remember, f prime of x was the equation of the slope at any point on f of x, but we need to find the specific x value for when f prime of x equals the slope of negative 1/2. Alright, so we set f prime of x, which was negative 1/2, x minus 1 in parentheses to the negative 3/2, equal to negative 1/2. You could do this the long, tedious way where you square both sides. You can take the cube root of both sides, times 2 and then divide by negative 1 and all of that. Or you could just see that you have a negative 1/2 here and a negative 1/2 here. So the only way for this to equal this is if this whole inner function was 1, right? So essentially you could just solve for it looking at it, and you see that x equals 2, because 2 minus 1 is 1, 1 to the negative 3/2 is 1, 1 times negative 1/2 equals negative 1/2. Alright, so that gives us x equals 2. Now for step 4, we need to plug that x equals 2 into our original equation, f of x. And this is the way we can obtain a y value for our tangent line equation. So original equation, f of x equals 1 over the square root of x minus 1. We plug our 2 for our x value. F of 2 equals 1 over square root 2 minus 1, which is going to equal 1. And this tells us that when x equals 2 in our original equation, y equals 1. Alright, step 5, now we're going to solve for the tangent line equation. The equation of a line, we know y equals mx plus b. We solved for m earlier, that equals negative 1/2. We have x equals 2, which we just solved here in step 4, y equals 1. So we can plug all our values in, and we get 1 equals negative 1/2 times 2 plus b. We solve for b, which gives us b equals 2. So finally, the equation of the tangent line parallel to the given line is y equals negative 1/2 x plus 2.